Hello, Assalamualaikum warahmatullahi wabarakatuh. I am FARIS ISKANDAR BIN ZAMANI. I am from section 11 of Digital Logic. So today I am going to explain you guys on a video demo on DIT circuits that me and my group has done for our final project. So our project is to implement a 3-bit synchronous counter count up and down to support 8 floors hotel elevator. So we are given a situation where there's a hotel with 8 floors and we need to design the circuit for an elevator. So for our circuit design, we are tasked to implement 3-bit synchronous counter with count up and count down because elevators can go up and elevators can go down. So we must show you guys about 4 inputs of K-map, for example X, Q2, Q1 and Q0, where X is the switch where you want to go up and go down. Q2, Q1 and Q0 is the output of the flip-flops. So 3-bit synchronous counter that we are going to implement is we will going to use JK flip-flops. So since this is a 3-bit synchronous counter, so we are going to use 3 JK flip-flops in our circuit design. Alright, so this is our job. So our additional features about our elevators is that we are going to introduce more features to the input controllers, such as to detect visitor card hotel, to indicate door open and close, and to use passcode. So this is the reason to allow for more security measures for the elevator system in a hotel room. Alright, so this is our DIT circuit. So as you can see, so let me zoom out just a little bit. So this is our general overview of the DIT circuit. So as you can see, it's quite complex and quite in a good shape. Alright, so before I go on the elevator system in a hotel, how they work, so let me explain one by one how these components make up an elevator in a hotel. Alright, so first things first, I'm going to talk about the counter which the elevator uses. So we are implementing a 3-bit up-down synchronous counter using JK flip-flops. So as you can see right here, these are JK flip-flops. You can see this J and K with outputs Q and Q bar and with the preset and clear as well. So these JK flip-flops are implemented to make a counter, synchronous counter, under the same clock input signal. So for this case, we use the elevator, we use the clock enabler down here. So the clock enabler allows us to transform from one level to another level without skipping anything. So the JK flip-flops are connected to the preset and clear switches up here, as you can see. So we are connecting each of the flip-flops with each corresponding output to represent the binary values. So this is to ensure that the output is comparable with up with the down with the things down there. Alright, so this is a door indicator of the elevator system. So whenever the elevator is moving, so it closes. So whenever it reaches the desired floor, so the elevator will open its door. Alright, so down here there's another switch for our DIT circuit. So right here is the X switch. X switch determines the elevator to go up or to go down. So for our case, when X is equal to 0, it's equals to count down, and when it's equal to 1, it's count up. So if you want to go from level 1 to level 6, you can turn this switch from 0 to 1 so that when you run the elevator will go up. Alright, so moving on. So there's a clock switch over here. So since we are using a clock enabler to enable for the system of the elevator system, so we need a clock switch right here, a power button down here, and a start button down here. So in addition to that, we are installing another feature where the user can key in which floor they want to go. So for example, if they want to go to floor 6, they can just turn on these switches and they can go to the desired level. And we need to also repetitively click on the clock switch with other things as well. So before I go deeper into that, there's another visitor card how to switch right here. We implemented a security feature for the elevator, whereas the visitor, if they want to use the elevator, they can use a visitor card hotel to detect, and then the elevator can start moving. Apart from that, we use a 3-bit comparator down here. This is to ensure that when the user key in the value to go to which floor, and then it compares the binary values up here, so that the comparator allows us to compare the values whether it's equal or not. So the NAND gets here, inverts the signal so that whenever these binary values down here and up here are equal, it will stop the counter from counting. Alright, so down here, as you can see, there are another 4 components down here. So this is called decoders. So each decoder is connected to 4 input switches and another one hexadecimal value display. So this is for the use of passcode. So we implemented another security measures for our elevator system, which is passcode. So passcode when is only if and only if entered correctly, the elevator will only run. Alright, so that's all for the introduction. So I will go straight away to the user manual down here. Alright, so before we do the start, so we need to start the simulation first by clicking this button, start animation. Alright, so as you can see, so once we do this, you can see that the displays have, display over here. Alright, so first things first, we need to go to the user manual here. So the first one is that we have to switch on the preset and clear button. So the preset and clear button, like I said, is up here. It's connected to 3 of these flip-flops. So turn both of these switches on. So as you can see, the values here are updated and also the current flow. So which means the elevator is at the ground floor. Alright, so moving on to the second one, the switch on power button. So switch on power button is located at the elevator side. So here. So we just turn this thing on so that the elevator can operate, can start itself. So number 3, select countdown or count out. Okay, so in our elevator system, we need to decide the user himself or herself need to define in which direction the elevator is going up. So for example, if we want to go to level 6, so level 6 is 110 in binary. So we need to turn this switch into 1. So you can see here, when this is X switch, we need to turn this thing into 1 so that the elevator will detect this, and when we run the clock enabler, the clock switch, and then the elevator will go up as accordingly. Okay, so number 3 is done. So number 4 is select floor. So select floor is based on the user. When they enter the elevator, they need to key in the floor that they want to go in the hotel. So referring to the previous example, so you want to go to floor 6, so just enter the switches 110 in binary, and then we want to go to floor 6 over here. Alright, so before I go deeper into that, I just want to mention about the door indicator over here. It indicates the elevator's door is open or not. So since the elevator is not yet moving, not yet starting itself to move, so the elevator's door is still open up here. Alright, so moving on, so number 5 is tag in visitor card. Tag in visitor card is actually an input switch over here. It just allows the system to detect whether the visitor has visitor card or not. Then we just turn this thing on, and then yeah, it satisfies that. So number 6, key in passcode. So key in passcode is down here. The decoders that you see a lot of here. Alright, so this is our decoders over here. So we need to key in, the user need to key in the numbers, the correct passcode in 4 bits in the length of 4. So my friend here, he made a passcode. The correct passcode is 8964. So we just need to enter 8964 in binary values for these 4 input switches, or 16 input switches for each 4 of the decoders. So just enter 8 is equal to 1000, as you can see 8 over here. So for the second one is 9, so we just enter 10 0, 1. As you can see, it's 9 over here. Alright, so for the third one is 6. So 6 is equal to 0, 1, 1, 0. As you can see, 6 here. And lastly is 4. 4 is 0, 1, 0, 0, 4. Once the user has entered the passcode correctly, only then the elevator could work accordingly. So the last one, not least, is the switch on the start button. This occurs at the elevator for the elevator to start. So clicking the switch on will make sure the elevator will start to move. Okay, so I just want to recall back about the door indicator open or close. Okay, look over here. The door is open, so when I turn this thing on, look at the door indicator, it turns to 1, which means close. So this means that the elevator will start to move. So in order for the elevator to move, we need to click on the clock switch down here. So the clock switch is important in order for the elevator to move from one floor to another floor one by one. Okay. So by that means when we click on the clock switch, as you can see, it updates the value of the current floor of the elevator. So since we want to go to floor 6, so we need to repetitively click on the clock switch one by one until it reaches the desired floor. So as you can see, the door indicator is still 1, it's still closed, and we are almost there at floor 6. So once we get to our desired floor, the elevator will open its door, and then the number 6 will stay on its path, will stay on 6. Despite having we click on the clock switch multiple times, as you can see, the value does not update. This is because we implemented a 3-bit comparator down here. It compares, like I said before, the comparator compares the value from down here to up here. If it's equal, based on this logic circuit, 3 XNOR gates and a NAND gate down here, when both of these binary values are equal, so the counter here will stop its operation. Alright, that's just one example. So how about if I want to go from the high level to low level? So for example, we are level 6. And let's say if you want to go to level 2. So level 2, alright. So make sure you have to change the X switch from 1 to 0. Here, change this to 0 so that the elevator will go down. Alright. So what happens after this is that you need to make sure all the conditions are met, and the user must key in the number of the floor they want to go. So if they want to go to level 2, so which means the binary is 0, 1, 0. Change the floor number here like this. And then as you can see, the elevator floor is now closed. And the current flow is still 6. So the next step is we need to click again on the clock switch multiple times repeatedly until it reaches floor number 2. And when it reaches floor number 2, the door will open and the counter will stop moving. Hence, the elevator will also stop moving. So that's how our did circuit implementation on an elevator system on a 8-floor hotel. So that's all from me. I want to give a very big thanks to all of my group members, Hail, EMMADULLAH, and Jinyang. I'm very grateful for their hard work on this project. As you can see, this did circuit. This is our general view of our did circuit. And that's all from us. Thank you very much and have a nice day.